appreciate that. Yeah, I'm really looking forward to this. I think you guys both had some great ideas recently, and I'm looking forward to it. Can we just start and maybe let's see, Ben can go first, and then David. Just say a couple words about who you are and what your interests are.
I'm a former stockbroker with a background in economics, and I'm currently studying the economics of collective intelligence, looking to put together an understanding of how people get along and accomplish things that no individual can.
Cool. I am by training a software engineer, but I've been into AI ever since high school, reading Age of Intelligent Machines, and then just kept dipping in and out of the AI field and kind of being like, it's not ready, it's not ready. After college, I co-founded one of the first AGI startups with like Shane Legg, one of the DeepMind co-founders, was our first employee. So like back in 2000s. And then went to work at Google and Facebook and then Asana, mostly either working on ML, but most of my time has been building like large scale distributed systems. So really coming at this more from an engineering background, but also about 3 years ago, I left my job and dove back into AI and came across Carl Friston's work. And I think that's when it kind of all clicked for me. And I was like, wow, we have GPUs now. We have a theory of intelligence that I feel like basically covers, it's like, I don't think there's any more secret sauce. It's like we kind of, the formulas from active inference look a lot like formulas from traditional reinforcement learning. We have the hardware now. So I just like got really excited about it and have been working on it. So that's like my software and engineering side. I also co-founded Plurality Institute with Glenn Weil, who's like an economist, and that's more on the human collective intelligence side. Essentially, we're trying to create a new field, academic field called plurality studies that focuses on scaling human cooperation and collaboration, essentially collective intelligence as an academic field. And we've been bringing together researchers from like political science, computer science, economics, peace building. I mean, it's such an interdisciplinary field of like, how do we help humans cooperate and using technology, and now especially AI to bridge people. So that's kind of my other project. But my main research focus is, and I can share a little bit of like the research that I'm working on, and I would love help and collaboration, and also would love to hear how you guys are thinking about this and if I can help, because I think this is like the most exciting thing that's happening in the world right now.
Cool. Yeah, please go for it.
Yeah, so I will say, yeah, so Glenn Weil is an interesting name because I think he's got a very important idea, which is that we should be using markets to solve more problems, because there's basically a perspective in economics that says anytime you've got a problem, there's a market that can solve that problem. And people just haven't been creative enough historically about what kind of markets you can use. Like, we're just very used to like trading like standard property rights and things. And there's a lot of other ways you could conceive of doing things. I like the fact that Glenn Weil is pushing that. I'd be interested in, so I don't actually know what he's doing. So actually, I'm just curious about that. I don't actually know what he does with AI. So can you just tell me a little bit about what he does with the Plurality Institute?
Yeah, well, Plurality Institute is more of the academic, like human collective intelligence, of which AI is like a tool. So, for example, I mean, markets are one collective intelligence system, but then there are other ones, like even like comment sections on forums are a collective intelligence mechanism where humans come together to synchronize on epistemology, like on things that they know and believe, and being able to use LLMs to say automatically de-escalate flame wars in comment sections and drive people to consensus is like an example. In terms of the more economics things, so using quadratic funding for like public goods funding is something he has been writing about. Creating identity, like trust networks to create social identity, so that you can use that as infrastructure for all these other like market mechanisms is another one. There's someone that's working on vector prices. So rather than there being a single price signal, there's a whole basket, collection of currencies that you hold, and then people can specify their own values for different currencies. And then the way the trading works is basically when you're trading with people that are aligned with you on values, you automatically get discounts because they value your currencies more than they value some. So there's like a whole bunch of them. He just has a book out. Open source is like another, like how large open source projects are incentivized and how collaborations occur without like a corporate structure. He has a book out now called Plurality with Audrey Tong, who's another inspiring person. So I would check that out, and that's like is going to cover a lot of different aspects of like plurality and collective intelligence.
Cool. Is a lot of that just on the Plurality website?
The Plurality Institute website, we like post events and talks, and we have the link to the Plurality book, but the Plurality book is like much more detailed.
Cool. I will check that out. So maybe what I can do then is just kind of give a broad overview of what I think the basics of economics of collective intelligence are, and we can see how that relates to our work. Cool. So the way I see it is that collective intelligence is all about getting people to communicate in honest ways, in honest and relevant ways, such that everybody forms a shared model. And because everyone's behaving with that same shared model, everyone ends up behaving as if they're all following the same, sort of commands, if you will, of like a dictator or a virtual governor. And everyone ends up nicely coordinated. To achieve that kind of signaling system, you need something that's analogous to a price system. And what that allows you to do is its principles very similar to what Mike has talked about in some of his work, where you get a way of getting an entity to see questions about other people as questions about itself. And so like information gets transmitted in such a way where like when someone else is in trouble, you perceive that as stress to yourself. When something benefits someone else, you perceive that as benefit to yourself, which we see very easily in the price system. Like if someone needs more food, they'll, have a demand for food that'll raise the price of food. So that stress gets transmitted to everyone else who chooses to buy less food. Or similarly, if you help someone get food by supplying some food that they like, their benefit becomes your benefit via the revenue. You make some money. So that very simple system ends up outlining really just the basic functionality of a collective intelligence. I think that any collective intelligence probably follows basic price-like principles, where you need some system where people are incentivized to communicate honestly with each other, and such that everyone's signals gets condensed into like your own personal situation. So just by optimizing for yourself, you end up inadvertently taking care of everyone else. So are things like that, when you're looking at like AI and technology and stuff, like I don't know what goes on inside a computer. It's all magic to me. So is that what's going on with like the transistors? Do they all have their own like individual model and they end up like communicating to form a shared model?
I mean, I guess at some level, everything is doing all of this, right? Everything is like mutually reducing free energy, and you can treat every part of the subsystem as an agent. So in some level, yes, but I think what you probably mean is more directly in a computational way. Like typically what we do now is we train neural networks, which are a big pile of math, but essentially it's a thing that learns function approximations, and the way it learns function approximations internally, and we're still studying, what actually happens internally, but probably, yes, things get partitioned into sub processes, like sub functions with sparser communication between them. So kind of what you're describing, like if you think like in your model, an individual is this like very interconnected system, and then it has these sparse connections to other deeply interconnected systems. And this is like, a cell is doing a lot of compute inside, but then it's got just like a few membrane exchanges with the outside. Or corporation, there's a lot of stuff going on inside, but it communicates with the rest of the economy via buying and selling products. So in some sense, anything that you partition into subsystems is essentially doing this. It is using some form of information, like sparse information propagation between units. In terms of honesty, I think that's a lot trickier, because it's like the communication doesn't need to be honest. It needs to be valuable. I think there is like a theorem that like for communication to exist, it has to benefit both parties. And so there has to be some value to it, and you can maybe say that value is the truthiness, and so you could like maybe decouple it into like signal and noise. So there's like some truth value, and then maybe there's like a bunch of noise value. If it's all noise, that communication channel is just not going to persist. And so in terms of, I think when you're like, hey, there should be honest pricing mechanism, I would instead say there should be the two agents or whatever, the network of agents. There needs to be ways for them to communicate usefully with each other, which maybe is the same thing, but they kind of co-discover what that is, and that doesn't necessarily need to be imposed by a mechanism. But if a market mechanism or some communication framework allows honest communication channels, then you're making it much easier for them to discover how to use it. I don't know if any of that resonated.
It does, and maybe there's something interesting to work out here. So economics has been talking about the importance of getting people to communicate honestly to achieve coordination for a long time. And sort of the basic picture of that, which is very, very silly and false in some ways, but also maybe important for intuition, is if you're trying to centrally plan an economy, one conceivable way you do that is, you have an allocation problem. Who should get what goods? You could just send everyone like a giant questionnaire and say, like, do you need a new pair of shoes, etc. And the problem with that is that people could lie and they could say, yeah, I totally need a new pair of shoes. And so there's a lot about that picture that's very unrealistic, but figuring out ways to get people to honesty is maybe a word that has some bad connotations because we interpret in terms of like deliberate intention and like moral character. It's really more just about like truthfully conveying your intentions. So so basically, maybe this is a way of thinking about it. You can sort of think of economics as a very complicated version of like of traffic. You're just trying to get cars to not crash into each other, and that means that each car needs to predict where each other car is going. That means each car needs to be sending very clear signals. I'm definitely going here, and I'm not going to like turn suddenly or something like that. So you're trying to get people to convey what their plans are so that everyone knows what everyone else is planning. And so then they can pick a plan that's consistent with all those other plans. And I guess this is valuable. It's like much more of like, I guess, an information theory kind of take.
I think there's another thing that is missing from that model, which is that if you have like a really narrow freeway, then some cars are going to get through and some cars are going to have to wait. And there's not an easy way to resolve which ones. So I think and this is kind of back to the plurality way that I've been thinking about it, is like, these are all forms of alignment. And I break alignment down into like aligning on action, which is kind of what economics in some sense lets you do, is like, okay, we all have common beliefs. Given our beliefs, what should we do and how can we coordinate our action? How can we all send our routes so that we don't collide. So that's kind of aligning on action. There's aligning on epistemologies, like how do we all come to believe the same world models? And then there's aligning on value, which is how do we actually, like, I want one thing, you want a different thing. Maybe we want opposite things. How do we align on that? And all of these three systems are all interdependent, because if you actually want different things, you're not going to necessarily even align on epistemology, because the things you know are only things that you care about enough to know. And if you care about different things, you're not even going to necessarily ask the same questions of the universe to get back the same knowledge. And if you have different beliefs, you're not going to align on action. And they all have to be iterated. So like if you can agree on the same epistemology, then maybe you can both shift your values, because what you value depends on what you know. And so in some sense, it's like you have to pull all of these three systems in. And I think that's another cool thing about it. Economics is it also does help value alignment and knowledge alignment, because prices are knowledge signals. So they tell you know what goods are easier to get when, and they're also value alignment mechanisms, because they allow you to trade something that you value more for something that you value less. So I think there are these pieces, but they all have to kind of play together.
So I want to go in a couple of different directions with that. And maybe the first thing I'll mention is actually pulling away from economics a bit and talk about some neuroscience. So on a different comment I left on Mike's blog post, I talk about the work of Lisa Feldman Barrett, who's done super important stuff. It's actually her work that really prepared me to understand what Mike's talking about, because I don't know anything about biology. And the active inference sort of predictive coding view of things that she's really advancing as a way of understanding what the brain does, sort of we do often naturally draw these divides between knowledge, acting, and valuing. And the active inference way of viewing things very much pushes all of that together. It's actually more like action that drives perception, and really your goals are at the base of all of that. But also your goals are determined by, I think of goals as basically like beliefs or measurements that you have. So like your goals are, in a sense, your epistemology, because your goals are your measurements about the world and your prior expectations. It's a weird sounding view, and maybe we can talk about that, but that's kind of how I think about that. And so I would, it's very useful sometimes to separate these things out, because there's a reason we draw these we categorize, because there are practical reasons to do so. And so that can be useful, but also I want a fully unified perspective where we're just treating all of that as kind of the same thing in some level. And in economics, at the end of the day, when you're trading something, you can disagree very strongly about, like the trade ends up compressing all of that. Like if I'm buying shoes and the reasons I'm buying that would make no sense to the shoe seller, as long as I like the price, everything else is fine. So yeah, I'm not quite sure what the balance is there. It's because sometimes it feels like you do need to address things like that, and sometimes it feels like it just takes care of itself when the system is set up right.
If you guys are up for it, I made a couple of slides and videos. I'd love to share. I don't know if that would be a fun. Is that okay?
Yeah, go for it. Let's see.
Cool. Okay. Can you see my slideshow here?
Yeah, we can. Yeah, any chance you can full screen?
Yeah.
Yeah.
Is that better?
Much better. Go for it.
Cool. And this is two different ideas that kind of work together that I want to get both share and get you guys' feedback on. I'll go really fast and then we can drill into something. But essentially, the thing I'm really interested in is how do we make an AI agent? To define an agent is basically something that takes past like a sequence of past observations and then produces the next action. So it's just, I think of an agent. I know, Mike, you think agency has goals, but those are externally observable knowledge about an agent. I think that's interesting to figure out. So for this thing, I think of an agent as just like some function that, given a sequence of
I think you're breaking up for me.
Yeah, me too. Me too.
And we can,
Sorry, David, I don't know if you can hear me, but I'm not getting any of this.
Yeah, me too. I can't hear what he's saying.
Technology's not a friend today.
I guess he'll try again. Yeah, I've noticed that usually happens when something really interesting is about to come out.
It's because it knows what we're doing and it doesn't want us to make progress on these questions.
Yeah, there's a little bit of that. Yeah. Yeah.
Is that background somewhere you've been?
Yeah, this is years ago. This is Alaska.
Oh, nice. Okay. I think I've been to Alaska, but many years ago. I don't remember much about it.
Yeah. Yeah, it was pretty incredible.
This is my blank beige wall because I have that kind of apartment. So
yeah, cool. Well, yeah, hopefully he'll come back. If not, we'll just chat.
So actually, I do have something I should address with you quickly.
Go for
So
it.
regarding the paper we've discussed, I just want to briefly mention to you, I don't know a lot about collaborating on papers. And if there's something that you might expect a collaborator to be doing right now while you're working on other things, that might not be obvious to me. Is there anything specific that I should be doing right now?
Remind me where it stands. You've sent me a draft. I'm
I've
gonna get.
sent you an outline of
Okay,
yeah.
then it's stuck in my court. So I've just been
Cool.
insane. So I will get back to you within the next couple of days with it. So yeah.
Oh yeah, and no rush. I just literally wasn't sure if there was something
Yeah,
I should.
it's not you, it's me. I've got a stack of drafts on my desk
Understood.
for these things.
Yeah.
I will get to it. Yeah. Okay. Let's see. David is maybe back.
Can you hear me?
Hi, David.
Hey.
Hey, sorry, my computer decided not to run Zoom anymore, so I'm on my phone. Um, okay, let me try to just do this without the slides. But basically, the idea is that like an agent is essentially some function that maps past observations to the next action. And general intelligence is essentially a set of behaviors of like, I think in your paper, Mike, had this thing where it's like, how do we navigate a space, how do we adaptively and intelligently learn to navigate arbitrary spaces? And I think of that as just like a collection of algorithms that let you balance exploration and exploitation. Essentially, it's active inference, but active inference requires perfect Bayesian inference, and really everything just implements an approximation. So the question is like, how do you learn or build an approximation of active inference in various spaces? And neural networks are function approximators that instead of building, you can train given the right input-output pairs. So the idea is to basically train a neural network that's a function approximator of intelligent space navigation. And I think the way to do that is agents are basically duals of their environment. So if you want to train an agent to do something, you need to give it an environment where achieving fitness to that environment gives you the behaviors that you want. And so I think if you want an agent that's able to generalize learning, you need an environment where there's always something new to learn. And that the behavior space needs to be dense enough that the agent is able to always discover some new thing that it can learn that gives it adaptive fitness to the environment. And therefore, as it is learning how to adapt to that particular environment, it is also generalizing learning. It is meta-learning learning. So the idea is if you can give an agent always some new environment where there's something new to learn, it's going to learn that. And it's also in the process of doing that, it's going to learn how to learn. It's going to learn, how do I balance exploration exploitation? What algorithms, what sampling algorithms can I apply to this new space? How do I leave myself engrams? Like, how do I store memory? How do I structure memory? How do I interpret memory in these various ways? And so what you want is an environment that essentially gets harder or different as the agent gets smarter. And I think the way to do that is make the environment, and I think the way evolution did this is make the environment highly multi-agent, so that what you're like, there is complexity in the physics of the environment, sure, but really most of the complexity is in the minds of the other learners. And this kind of goes back to economics and capitalism, where markets are kind of anti-legible. As soon as you find out some trick that gives you an advantage in the market, that advantage goes away because it gets arbitraged away by everyone else that learns it. And so I think you kind of have this with multi-agent setups, you kind of can get into this infinite game where as the minds of agents get more complex, you have to get more complex to be fit in that environment. And this is kind of just like creates this intelligence treadmill. And I think this has been done in AI. So this is how we get like Go player or chess players. It's like they do self-play against themselves, and as they get better, the game gets harder. But I think typically this is done in purely adversarial settings, where and with an fully adversarial setting, you basically cannot explore a lot of the behavior space, because as soon as you deviate from some dominant strategy, you get exploited by all the other players. And so it's very easy to just get stuck at local minima, because there's not a lot of ways to deviate from local maximum. You basically have to really discover something new really quickly, or you just get outcompeted by people that are doing the same old thing. And I think the fix to that is basically blending this line of what an agent is kind of in this collective intelligence sense. I think one really strong technique for that is kinship. So if you're in a world where other agents are, say, a lot of the agents around you are your brothers or your clones or your cousins, essentially this whole spectrum of kinship, then another way to think about agency is kind of, if you have two agents that share the same goal, you can think of them as one agent with just like really bad cognitive architecture, where instead of just being able, it has to like learn how to pass messages to itself. So one way to define agency is via essentially goals. And kinship is this way of aligning agents on goals. So if you have an agent that 100% shares the goal with another agent, it's basically one agent. If it's 70% sharing goals with that agent, then it's kind of this blended super agent. And so the idea is, if you have an environment where all these agents are aligned with each other with various different kinship relationships, you can create this really high dimensional behavior space where you're not always competing. There's a million different ways to cooperate, form coalitions, break coalitions, establish trust. And so the idea is, can we create a relatively simple, fast to simulate in silico virtual world full of other agents? The agents are aligned with each other in various kinship scenarios. And then we scale up then we train larger and larger neural networks to drive those agents and get to LLM size, billion parameter models that, instead of predicting the next token, are predicting the next action that an agent should take given all of the experience it's seen. And so the idea would be that if you give an environment like that, you're essentially providing a gradient towards increased intelligence, and then you're using standard machine learning techniques to train a function approximator for that to follow that gradient. So that's kind of the idea behind like the overall environment. But then the other thing I wanted to incorporate is this collective intelligence approach. And I really wish I could present my slides. I don't know what happened with my computer. Maybe I'll pause for a second, let other people speak. And I don't know if anyone has feedback or thoughts or criticisms. And then I'll try to see if I can get this other slide to work meanwhile.
Yeah, thank you for that. I mean, I have certainly heard a somewhat similar sounding theory that evolution evolved or intelligence evolved as some sort of, social competition, that, primates competing with primates and birds competing with birds is where it comes from, rather than trying to build tools and so on. So, yeah, the idea about, you need a form of some kind of protection, some ability to innovate. I mean, there's a lot of aspects of economics where there's this challenging tension between wanting to optimize and wanting to create room for innovations. Like perfect competition is a classic example. Like you learn very early on, perfect competition, you're going to maximize price, maximize output. Your price is going to be as low as it should be. But it's very hard to innovate in perfect competition because the way the model works is whatever new technology you introduce, everyone copies that instantly. You make no profit. So, but you're the one who made the investment, so that just sucks. So a little bit of monopoly can actually be helpful because that way you're making money. And then there's even artificial things like, like patents and stuff that give people monopolies to try to incentivize them to make those investments and innovate. So that is a very important aspect of intention of any sort of collective intelligence system, is trying to encourage parts of your system to improve and do better, and trying to protect them from parts of the system that might say, oh, we're going to copy that, we're going to take that, we're going to steal that. There's a part of this that maybe, I know you're trying to get your slides up, but I saw in your talk, you talk a little bit about like love and stuff at the end of that. When you have a talk on YouTube, and that's something that I had wanted to bring up because I am working on a couple of papers about moral psychology and neuroscience, including a paper on morality as a form of cognitive glue, which it isn't really, but it's a sort of an interesting counterexample in some ways. And basically, there's a model in which kinship. Let me ask you this. If suppose that you took all the families and you rearranged them, like people didn't know that they were in the wrong families, but you had families where no one's actually related to each other genetically, would the system still work?
Yep. Yeah. So I think of this as I think of this as essentially reward sharing. So on a genetic level, the genetic optimization process gives rise to organisms that care about their kin, right? So because a gene is present in the kin, that it's going to make the organisms that come from it want to help other organisms that have that gene. From the gene's perspective, it doesn't matter whether you reproduce or your brother reproduces twice. And similar, so essentially, the behavior that an organism exhibits that we call love is basically what it looks like when the underlying optimization process shares rewards or shares rewards between organisms. But then the organism itself, one of the things that it evolves or learns or whatever needs is some way to recognize who it should care about. So we have all of these heuristics for knowing who our kin are. Once those things are in place, it's the heuristics that matter, not the underlying gene. So I think if you train agents that see other agents and you give them a reliable signal that, hey, helping this agent is actually the same as helping you. So every time this agent, something good happens to this agent, you get part of that reward. And here is a marker that tells you who is kin and who is not. The agent is going to learn behaviors that are conditioned on that marker. And then once you stop training and you just let these agents go around behaving, you can change that marker arbitrarily. Rewards are no longer even there, right? Genetic evolution or whatever has stopped. Now you're no longer learning a new policy. Now the learning is happening inside the mind of the organism, not inside the genes.
Okay.
Is conditioned behavior on kinship markers. Did that make sense?
It does. And there's a very important paper that anyone interested in this should read. It's called The Sense of Should, a biologically based framework for modeling social pressure. And in some ways, maybe the difference is subtle, but I think there's a way of looking at these sorts of morally motivated cooperative behaviors that does not, in fact, depend on any kind of evolved pressure to care for or intend to cooperate, but instead it's just like something your brain just constructs as a living organism in its environment because it's trying to make its social environment predictable. And so there is something of emerging perspective, and my papers are somewhat drawing on this research that's basically saying, let's not think about evolution, let's not think about long-term cooperation, let's just think about trying to make the social environment environment predictable. And that's how we can actually get these cooperative and moral behaviors. And so that just might be something to look at, because that's another paper release as a co-author, and I just bring up Lisa's stuff as much as possible.
I mean, this is also
Yeah, I mean, go ahead, Michael.
sorry, I was just going to say that also sounds like Imperial model of multicellularity that Chris Fields and I published a bunch of years ago, which is basically that, you know, if cells are trying to predict an uncertain environment, the least surprising thing around is a copy of yourself. And so this can be a driver for making cells stick around after you've divided to form a highly predictive surrounding for yourself, so that you live in this niche, and then the frontline infantry is out there facing the uncertainties of the outside world, but you can predict them because they're you, and so it's a lot easier that way, right? So you can think about it that way as well.
Have I talked to you about comparative advantage?
I have
yeah.
No, I don't think we've
I want to.
Go ahead, David.
Sorry. Yeah, sorry. I had a question about that, Michael. So if you have a cell and the cell does, given situation A, it does random stuff, then being surrounded by copies of those cells, and you do random stuff and your clones do random stuff, being surrounded by cells that in that situation do random stuff is not actually going to help you predict the environment. So I think there's something more to that. It's not that being surrounded by copies of yourself gives you the ability to predict your environment. I think it's being surrounded by copies of cells that want to make your environment, that want to help you make the environment more predictable, that actually matters. Right? Unless you think that a cell, by being able to introspect itself, can predict the behavior of other copies of itself.
I mean, I don't think they're likely to be doing random stuff. There are probably situations in which the response is kind of random, but I don't think that's the vast majority of what cells do. And so I do think that if you're it's easier to anticipate cycles and responses. I mean, again, I think you're right. If it's random, it's not going to work. But I actually don't think that cells are random in that way. But let's anyway. Let's let David do his thing.
Oh, okay. Yeah, this is just so this is actually mostly inspired by your work, Michael, and economics. So I'd love to get thoughts on this. But okay, so this is the standard reinforcement learning formulation, right? You have an environment, you have an agent. The agent takes an action in the environment, it gets back some observation and a reward, and then it learns to act in a way that maximizes reward. And you can have a dual formulation, which is active inference, where the agent is trying to predict observations. But essentially, this is the normal kind of loop. And typically, the way it's we can break this down into like an agent. Basically, there's a bunch of observation states from the environment that go into the mind. The mind is going to generate a bunch of actions over actuators. There's some memory that maybe the mind has that it's reading and writing from, and it's getting a reward signal. So this is how we train agents in reinforcement learning, or this could be trained or this could be evolved, doesn't really matter. And so the way we do this now in the field of RL is you have this giant neural net inside the mind, and there's model free and model RL. So they're like, this is skipping over some detail, but essentially you're training this big blob of math that you're jiggling using gradient descent to optimize your long-term expected reward. And it is learning how to compress and basically how to compress the observations into latent states, maybe store parts of those latent states in its memory that then it can reinterpret, and eventually to generate actions. And so these networks can be giant. in language models, there are hundreds of billions of parameters. In reinforcement learning, they're much smaller because we just haven't figured out how to do it yet. But this is kind of the standard setup. And what I am proposing is a different architecture that is essentially, instead of there being one mind, there are many individual agents. Each agent is mapped onto some subset of the observation space and some subset of the memory space and some subset of the action space. And they can be mapped to any or all of them. But essentially, rather than training one brain, I want to train a neuron that in a collection, when you put it together in a graph of other neurons, knows how to co-organize collectively to solve the overall problem that the brain has. So rather than training 100 billion model network, I want to train 1 million parameter network that when you copy and paste it and throw it into this soup of other neurons will self-organize into solving the problem. And so the idea is, rather than having to learn adaptive algorithms, so in this way, you can imagine that there's an algorithm that you apply to many different parts of the sub-problem. But this network has to learn that algorithm in a bunch of different places, because every sub-function call might have the same kind of, oh, this is just like a regression problem. But you have to learn how to solve regression in a bunch of different places. Whereas here, this thing can just learn, okay, here is how I divide my problem into sub-problems and send those messages out. Or here is how I pay attention to a pattern happening at this time scale, and that's my job. So the idea is to break down this one big blob of compute into something that can be done on this graph instead. And I think, and this is why I wanted to talk to you, Ben, because I think basically I started out thinking, well, this is an economy. If these things were, if the observations and memory were commodities, and these things were like buying and selling those commodities or something like that, that would give us. So the question is, the inside of a neural cell is a neural network that we train. But then the question is, what is the cognitive glue between all of these neural cells? Essentially, what is the protocol that they use such that when we train the neural cell on the overall objective, they'll learn something useful? And the thing I came up with, kind of influenced by active inference and collective intelligence, is so now this is inside a single neural cell, right? Now this is an agent that just sees some set of inputs. It has its own memory. It's going to get some reward signal from the cognitive glue, and it's going to produce some outputs. And I think the way to do that is that basically it should be predicting its inputs, active inference, essentially learning a world model of its little world inside the brain. And then voting on the outputs so that it can, and in this case, outputs can be inputs to another neural cell or just outputs to an actuator that moves the organism around. So I think essentially I'm proposing some kind of an agent who's that receives a set of inputs. So this is some subset. And it has some memory, and then what it's going to do is it's going to predict the output at the next time step, along with some bet. So it has energy, and it has finite energy. It's going to bet on what the values of the inputs are going to be at the next time step. It's going to vote on what it wants to set the outputs to, also using this energy. And then at the next time step, it's going to see, well, what were the actual inputs and which bets did it win? and then it gets energy in proportion to essentially gets energy back as a reward. So the idea here is that these agents are incentivized to only predict the inputs that they have a comparative advantage on over other agents. So the same input and output is mapped to multiple cells. So as an agent, you should learn to only to basically monitor your environment, form models about it, and then bet on the things where you have a comparative advantage to other cells. And then as you get more and more capabilities to model your environment, you get more and more energy that you can use to vote on steering around that environment. This is all hand wavy, and this is where I think I need help and help from economics, because I start out with pricing, then I had it actually be an auction, or a prediction market and an auction, and then I try to simplify it just down to just like straight betting market. But that's basically the idea: is can we come up with this like simple cognitive glue for a pool of these agents, and then train those agents? I'll stop talking now.
Yeah, no, that's very interesting. I think it's definitely an economy, and you definitely should talk to economists. I'm afraid, I think a practical issue is I'm just not sure economists have actually done a lot to explore this space, even in theory. For the most part, they've been content to just take the economy as it is and try to explain that. And there's been, I think, just kind of a sort of lack of creativity there in terms of envisioning other economic spaces and trying to think about building alternative economic systems like this one. So I'm afraid I myself don't have a lot of practical things to say right now that might actually be of any specific use to you, other than I think just affirmation that you're right, that this is economics and that talking to economists is a good idea. I think the mechanism design people are the place to start. I mean, I think that's where Glenn Weil comes from. Like, I don't know if like Eric Maskin is reachable at all, but like he won a Nobel Prize for that. And I had a 2-minute conversation with him many years ago that was very influential. So you might just want to see if you could send him an email and see what he says. Yeah, I think this is cool. I'm afraid I don't think I can help you today with it, but we should stay in touch, and I'll let you know if anything comes along, because this is very interesting and very important.